All right, we got started on the other video without starting the video. Here it is. We're going to do this mechanism shortly. Some biochemistry that you should take to your next classes. When you have a ketone becoming an alcohol, it's called a reduction. We're supposed to know that already. In biochemistry, you use the NADs for polar functional groups. NAD slash plus NADH are for polar redox. That means the functional group that's reacting is polar. Ketones are polar, so are alcohol. Okay? So alcohol, oxidation using NAD+. Why NAD+? Because that's the oxidizing agent. Oxidizing agent. Oxidizing agents either increase the number of bonds to oxygen, which is more electronegative. When you get bonds to more electronegative atoms, your electrons go further away from you. So, for example, I am a carbon. I am a carbon with a bond to H. In the beginning, I am a carbon with a bond to O, having replaced the bond to H at the end. The electrons used to be close to carbon in the bond to H, and now they're close to oxygen in the bond to O. That's called oxidation, when electrons move away. Okay? This carbon has no bonds to H. When it's done, it has a new bond to H. Where did it come from? NADH. This new H came from NADH. It's reduction. You replaced a bond to a more electronegative oxygen, where the electrons are closer to oxygen. You replaced it with a bond to a less electronegative H. The electrons moved closer to carbon. Moving electrons closer is reduction. This is a reduction using NADH. NADH is a reducing agent. Okay, so we got redox review when it really counts, because you're about to move it on to organic chem. Biochem, this is organic chem. We're doing NAD plus oxidation right here. But it says you're supposed to hydrate the carbonyl first. Everybody missed my clue. I don't think I saw anybody hydrate. I saw one student hydrate the carbonyl first. Yes?
I skipped because, I think I saw the study guide. That wasn't the first step, so I refuse to believe it.
Oh, I don't know if I had. This is a brand new one. This was never there. So she saw a different reaction on the study guide, and it wasn't this reaction. But I'm going to hydrate my carbonyl first, and I'm going to do a judicious circling. This is careful when you circle like this. I want everything up to, but not including that carbon. Okay? Everything up to, but not including that carbon is R. Okay? And I'm going to hydrate my carbonyl first. You got to protonate it to activate it. So you can attack it with water. Hydrate needs water. I hope I knew that. Oh, don't have my color scheme. There we go. And then we're going to neutralize the water with our enzyme. Neutralize the oxonium is what I should say. You're not going to neutralize the water. Water's already neutral. Color scheme, maybe I can copy it from up here if I'm lucky. Maybe. Oh, aren't you beautiful? There we go. Oh, wrong place. I wanted it here. Weird. Congratulations, you successfully hydrated your carbonyl. I got an R that goes to a carbon that has an OH on it. It goes to a carbon with a methyl and water on it. Oh, really? OH is new here. The old O is with a new H. There's your hydrated carbonyl there. Now what's going on? We gotta look at this one. This is like a critical thinking mechanism. I think it does look a lot like tautomerization. But it's real, it's an elimination. Here's your leaving group. If you're not sure, I'll draw it. H is bonded to O is bonded to C. Sometimes it just helps to think about how do I get from that to this, because that's just HO2CCH3, HO2CCH3 right there. What happened to this H? It's H attached to O. When I see it gone, I think acid base myself, always. And I know I used ends, but guys, you have ends available as many times as you want. Ends is your base. I wonder if we can get this thing done. Let's do our level best to make both that and that. I think I can get there. Maybe not. Maybe not.
I think summarization gets you
You're going to have to use an enzyme to grab an H. And I want to do one that's different than the answer key, but nobody has the answer key open. So it might be the same as the answer key. I can either grab an H and start the electrons flowing down here. You agree? Yeah. Grab an H, flow, and then the H comes and goes to NAD+. H minus has to go to NAD+. That's what NAD+ does, everybody. You forgot? Here's NAD+. It's not here. I got excited for no reason. I thought I had it on the previous page. I made NAD+. H minus flows away from NADH to make NAD+. I hope it makes sense that the opposite has to happen to go from here to here. You got to put the H minus back on. So I'm excited again. I got to get an H minus to attack this carbon of NAD+. And it can be this H minus or this H minus. It all depends on how you get the game started. And based on what I drew, I'm going to go with N's grabbing the H on the alcohol. Yes.
What about protein that wants the first C and then making the whole double bond to the C?
Protonate this O.
Yeah, and then make a double bond.
But I need that O in the product. That O is a ketone. It's this O.
Oh, okay.
Don't make it leave. Okay. I can grab this H to get the mechanism started and flow like this. H minus going to NAD+. Am I on the wrong NAD+? No, I'm not. We got cross red arrows up there. You know, I don't like it. It's okay. I'm going to erase this whole mechanism anyway. So you got that one on video. You could go that way. I'm going to show you a successful completion of the mechanism going with grabbing the other H and flowing the other direction. Here they go. They both should work. Can't promise anything, but I'm going to give it a shot. You ready? Grab that H. Sigma becomes pi. This becomes a carbonyl. H minus goes to NAD+. My NAD+ is too small. Oh, it's huge now. It's right up here. You ready? H minus is going to come with its electrons. Here it comes. attack that position, resonate, and N gets a lone pair. Just to verify, there's its lone pair. That's how NAD plus gets reduced. And are we surprised? This is a polar functional group right here. And we're using NAD plus, no surprise there at all, right? I'm glad you're not surprised. So I think this was useful more so for your days past this class, okay? Because this one doesn't even have a title. It's not on your list, so you won't see this one on Wednesday. Yay.
So wait, how many, are we gonna get any enzyme ones off the final or?
You're gonna get maybe 1 or 2 enzyme ones on the final, but there'll be strict versions of like the Claisen or Aldol or traditional mechanisms. I wouldn't count on too many enzyme ones, but really, please lose your anxiety. H enzyme is an acid when you need it. Enzyme with lone pair is a base when you need it. And then enzymes aren't special at all. That's all we're ever going to use them for. If you need an acid, it's the H attached to the enzyme. If you need a base, it's enzyme with a lone pair.
Picture HCl in your mind.
Yeah, HCl, Cl minus in your mind, sulfuric acid, sulfate ion in your mind, whatever combination you're used to in your mind, and then we're off to the race. Then my favorite mechanism is going to be last, and we better save before we do that.